So this video is going to focus on when you're given a function, when you're given a graph, how do you find the domain, range, x-intercept, y-intercept, and then find the given value or evaluate at a specific value. So we're going to jump right into example A. So example A, this is what an absolute value graph looks like. They always look like V's here. So it's always good to kind of just like skim over your graph, pay attention to a couple things, pay attention to certain points, what direction your graph is going in, that kind of thing. The first thing that we're going to answer is, what is the domain of this? So the domain is in reference to your x values. It's essentially saying, on the x-axis, how far out does your graph span? Is your span just from 1 to 2, this little section here? Does it span the entire x-axis? Where is it? When I think of domain and range, I think of where on your coordinate system does your graph live. If you had to give directions to someone, where is this graph? Is it over here? Is it over here? Does it span the entire thing? Where is it? Domain is in reference to your x values. Range is in reference to your y values. So as far as x values are concerned, you want to get in the habit of always scanning your graph from left to right. So domain and range are always given an interval notation. And what we know about interval notation, it's going to look something like this. So like, let's say, for example, I had the interval notation of -2 to 5. That means that my graph goes from -2 to 5, those points there. So it's an interval of where your graph is. So on the left side is where's the leftmost point that your graph hits. On the right side, what's the rightmost point that your graph lives at. So when I'm looking at this graph here, so it's a V. I do see on either ends right here, I do have arrows, and that's the assumption that this graph is going to keep going, which means that it's going to keep going out and out and out and out and out, and it's never going to stop. Now, if you have that situation, you're going to have a negative infinity to a positive infinity case because it just never stops. It's going to keep spanning the entire coordinate system. It's going to go off to negative infinity on the left, positive infinity on the right. Infinities always have a parenthesis surrounded by them. Remember that parentheses mean you can never actually hit that point. You can never get to infinity, whereas a solid bracket means that it is ending or it's stopping exactly at that point. Now, when we look at range, range is your down to up movement. So you want to start scanning your graph down, and then you want to make your way up. So if we're taking a look at this graph here, we don't have a graph anywhere down here. And we're looking at our y values, our y-axis. So we're doing this up and down thing here. So our graph doesn't exist until this point right here. And we're concerned with the y values. That's what range is. It's a span of your y values. So the y value for this point right here is a 2. So my graph starts at 2, and it's going to keep going up and up and up, and it's never going to stop because of that arrow. That arrow is pointing that direction. It's going to keep going, going, going. So our graph starts at 2, and it's actually at the point 2. There's a solid dot at 2, so I'm using a bracket. And it's going to keep going up and up and up, which means that's going to be a infinity with the parentheses. If you did a little more understanding on parentheses and brackets, I do have a video on interval notation that you might want to watch to get a better understanding of that. Otherwise, moving on to the x-intercepts. So the x-intercept is where does your graph cut the x-axis? Well, this is the x-axis right over here. Now, because our graph lives up here, it never dips down to the x-axis. It never crosses it. There are no x-intercepts for this particular example. It never cuts this x-axis. It just doesn't. Now, the y-intercept, we do have a y-intercept because if we take a look at our y-axis right over here, our graph cuts at this one point right over here. This is where it cuts through that y-axis. The point for that is what your y-intercept is. So if we give the point here, so remember a point is always given with an x and a y coordinate here. Our x coordinate is going to be 0 because it's right on the axis. And that is 0 and then up 1, 2, 3 to get to that point. So that is a 0, 3 for the y-intercept. The last thing with example A is we're going to evaluate f of 2. Remember f of 2, that 2 represents an x value. It is pretty much saying where x is 2, what is the y value for that. And I don't have points marked off necessarily here, so here's where x is 2. Right, and if we go up to our graph where x is 2, what we're looking for is what is the y value for this point right here, where it looks like the y value is a 1, 2, 3, a 4, where that hits. So f of 2 is equal to 4, right? The x value at 2, what is the y value for that point? So when x is 2, this is where it hits our graph. And if we go over to our y, we have a 4. That's how that works. Moving on to example B, starting with domain. Remember, domain is your x values, your left and your right. So if I start on the left-hand side and start scanning my graph does not start until the y-axis right over here, which is a 0. And it's going to keep going, it's going to keep going, and our graph actually stops at this point right here. We don't have arrows at either end of this graph, so we're not dealing with any infinities. Our graph starts at 0, and then it ends what looks to be a 3 right here. So our domain is from 0 to 3, and this little span here, 0 to 3, that's the only place on the x-axis that our graph lives. Now if we look at range, remember our range is our up and down movement, and you always start down to up. If we start down, our graph starts right over here at this point on our y-axis. This is a negative 1, 2, 3, 4. So our range starts at a negative 4, and it goes on up to this point up here, which is a 1, 2, 3, 4, 5. So from negative 4 to a positive 5, this section right over here is where our graph lives on the y-axis. X-intercept for this one here, so it looks like it crosses the x-axis right over here at that point. The coordinate for that is going to be a 2, 0. We move over 2, stay put there. The y-intercept at this point, now it does touch the y-axis, so we can still count that as a point. For the y-intercept, it crosses right over here, and that point is going to be a 0, negative 1, 2, 3, 4 for our y-intercept. The last thing here is we're going to evaluate the function for f of 1. Now remember, f of 1 is our x value, so if we look at our x value right over here, we need to see what is the y value that corresponds to that point. Well, it looks like a negative 1, 2, 3 would be our y value there. So when x is 1, y is going to be negative 3 is how that works. Otherwise, that's it for this video.